We will be doing the exercise 9.16 of language proof and logic. And I will be trying to show how to do it. And so the beginning of this is you'll notice is like this. The reason being that I completed it and I just opened the sentences in the world, so that when you look at 9.16, it'll say finally move C straight back to the back row and make the dodecahedron launch, blah, blah, blah. All your sentences other than 1, 2, and 13 are false. So that means 1, 2, and 13 are true. So if you did it correctly, which on 9.16, you should end up with what I have. So let's get to it. So for number 1, something is large. So this will be translated as there exists X such that X is large. Okay. Number 2, something is a cube. So remember, when you're using existential quantification, as long as there's something that satisfies being a cube, then this is true. And so you'd write this as there exists X such that X is a cube. Fairly simple. Number 3, something is a large cube. So remember, so now when you have is a large cube, you in Tarski's world, you're going to want to use a conjunct for this. So it needs a predicate X is large and X is a cube. So there exists X such that X is large and X is a cube, or vice versa. Number 4, some cube is large. Now, this is, you notice, very similar to number 3. And yes, you can actually interpret this or translate this using the existential quantifier in the same way. So it'll be such that there exists X such that X is a cube and X is large. And remember, some are tempted to write that some cube is large as there exists X such that X is a cube. If X is cube, then X is large, and that's not how you want to do that. When it comes to existential quantifiers, you use conjuncts. When it comes to usually when you're using universal quantification, that's when you introduce the conditional. So it's a good little thing to remember, is that existential, conjunct, universal, conditional. For number 4, so number 4 would be there exists X such that X is a cube and X is large. And if you could, so once you don't need to ignore all this and go through in 9.16 the regular stuff that it tells you to do by opening the Montague's world and check this and make sure at the very end you end up with this as what I'm showing, what I will end up showing you. So for number 4, some cube is large. Again, it's very similar to number 3, or is exactly similar to number 3. Number 5, some large cube is to the left of B. So there exists X such that X is large and X is a cube, and X is to the left of B. There you go. Remember, ignore this. So once you open Montague's world, it should all be true. And if it's not, then you're going to need to change it. So let's worry about number 6. A large cube is to the left of B. So there exists X such that X is large and X is a cube, and X is to the left of B. Remember, when you're using existential quantification, you want to use that conjunct. Number 7, B has a large cube to its left. Alright, so B has a large cube to its left. So you would say that there exists X such that X is a large cube, or there exists a large cube. X is large and X is cube, and B is to the left of X, or X to the left of B. My bad. And the reason why you don't want to, if you're going back here, you don't want to use conditional, right? Because it's not saying that, it's not, because if you were to do this, right, and say there's only one object that's, a large cube, right? And if, ignore that. So if you say that there's, only one, or if we're talking about this and you say that there's some large cube, there needs to be at most one, or at least one large cube, right? But that doesn't translate over to if X is a cube, then X is large, because what that means is that anything that's a cube, and then it would also be large. However, this isn't saying that. It's possible that the other statement's true, but for all we know, there's only one large cube. And to say that, well, there's multiple large cubes would contradict that statement. So that's why we don't use a conditional here, because it's not telling us anything about, you know, other cubes, or if there's even any other cubes. Maybe there's only one cube such that it's large, and that's why one of the reasons, some of the reasons we don't use the conditional. For number 7, B has a large cube to the left. I believe we already did this one. Yeah. For number 8, B is to the right of any of a large cube. So for this one, it's a little tricky. So B is to the right of a large cube. In other words, there exists x such that x is large, x is a cube, and B is to the right of x. So you write this as that. Now there isn't really any particular order that you want to do this, because if it's all true, you could separate the conjuncts using simplification, or once you use the equivalencies, the quantification equivalencies, you could use simplification and then just use it, and then a conjunction to add them all together and formulate whatever you want. So for number 9, something to the left of B is in back of C. All right, so something to the left of B is in back of C, meaning there exists x such that x is to the left of B and x is in the back of C. So there you go. Number 10, a large cube to the left of B is in back of C. So a large cube is to the left of B and is in back of C. So remember, continuously remember that when you use the existential quantifier, it usually means you're going to be using a conjunction. So for number 10, it would look like the following. There exists x such that x is a cube, and x is large, and x is left of B, and x is in back of C. Number 11, some large cube is to the left of B and in back of C. Some large cube. So remember, when you could think of some as there's at least one, or there exists some object as x, and so on. So some large cube is to the left of B and in back of C. So there exists x such that x is large, x is a cube, and then you add the other two conjuncts. X is a cube, x is large, x is left of B, and x is in back of C. 12. Some dodecahedron is not large. So some dodecahedron is not large, right? So for this one, there exists object x such that x is a dodecahedron and x is not large. And you write this as x is not large and x is a dodecahedron. Number 13, something is not a large dodecahedron. So it's this is similar to 12. So some dodecahedron is not large. In other words, well, no, not similar in the sense of identical, but you trying to use the not large, but it's formulated differently, so it might be a little confusing. So for number 13, it would be that there exists x such that x is not large and x is not a dodecahedron. For 14, it's not the case that something is a large dodecahedron. It's not the case that something is a large dodecahedron. So in other words, there does not exist x such that x is large and x is a dodecahedron. And x is dodecahedron and x is large. So in other words, if you're going to use universal quantification, you could write this as, so there does not exist x such that x is a dodecahedron and x is large. So it'd be that for all x is, you could do for all x is not f. And if you're using for all x is f, or there exists x such that x is f, and so on, and some other textbooks they do like that, and at the end of, such as like Dr. Sui Fan Lee's textbook, the one that I really like for introduction to logic. I don't know if I did her name correctly, but it's just a really good textbook to intro logic. I'd recommend checking that one out. So for number 15, B is not to the left of a cube, so there exists some x such that x is a cube, and B is not to the left of that cube. So there does not exist x such that x is a cube, and x to the right of B. I don't know if I said that correctly the first time, but that's how you do that one. So again, make sure that once you're finished here and you have these all aligned, they should all be correct when you translate them to Montague's rule. They should all be correct, and then you're gonna do the following steps. Move the large cube to the back of the corner of the grid, as it says in the textbook, and then at the end, when you are done doing everything, this it look exactly like this, or it should at least have the same truth values as this. And then you know that for the most part you'll be correct. And well, I hope this helps. Thank you.